Hey, what's up, and welcome back to Wind Chemistry. I'm going to go into part 3 of naming ionic compounds which contain D-block metals. So if you haven't done so already, make sure you go back and you watch parts 1 and 2 because I give you the basic foundation on how to name and write formulas for ionic compounds. This one has slightly different rules for D-block metals, but I think you'll pick up on this pretty quickly. Let's go ahead and check it out. We should all understand by now that the alkali and the alkaline earth metal families are +1 and +2 charges. Whereas if you're in the D block, you have various different charges because these metals can form multiple ions, many different types of ions. So for example, iron can form like a +1 or a +2 or even a +3 iron. You can have copper with a +1 or a +2 charge. Silver can form +1 and +2. Titanium can form a +3 or a +4 ion. So because these D-block metals form different charges, they follow a slightly different set of rules whenever you're naming or writing these formulas out. So you're going to notice that D-block metals will have their charge denoted by a Roman numeral. So that Roman numeral tells you what the charge of that D-block metal is. And then from there, you're just going to crisscross the charges like how we did in parts 1 and 2. So make sure you check that out again if you've forgotten how to do the crisscross method. As soon as you see the Roman numeral in the name somewhere, you know that it is the D-block's charge. Okay, so this is kind of hard to get students to understand, but that Roman numeral does not tell you how many irons or how many coppers or how many silvers. It's basically just telling you the charge of that metal. So for example, if you see like iron 1 sulfide in Roman numerals, you know that you're dealing with an iron +1 charge. On the other hand, if you see like a polyatomic, well, the rule still applies. If you see like iron 2 phosphate in Roman numerals, you see a 2, well, you know now that an iron +2 is involved. Let's check it out. Silver 1 sulfide. Silver has a +1 charge. Sulfur always has a -2 charge. And we're going to crisscross, bring the 2 down, bring the 1 over, write down what you see. So we have silver Ag2S1, which I'll omit. So this means a silver with a +1 charge. Okay, not the quantity. So it seems a little bit backwards, okay, because the formula is Ag2. So over here, this one is silver 2 sulfide, so it's Ag +2, which I'll circle. Sulfur still remains as -2, so when you crisscross the charge, you're going to get a 2-to-2 ratio, which remember, you're supposed to simplify. So this now becomes Ag(S). Okay, so that silver is actually a +2 charge. It's a silver with a +2 charge. Okay, so again, the Roman numerals are telling you the charge and not the quantity of silvers in the formula. Okay, so I just want you to take a quick look or hard look at this and then understand silver 1 sulfide is Ag2S. Silver 2 sulfide is Ag(S). Iron 1 oxide is written like this, so let's work it out. Iron has a +1 charge. Oxygen always has a -2 charge. Circle your charges, crisscross them, write down what you see. So Fe2O1, I'm going to omit the 1. So iron 1 oxide is written as Fe2O. On the other hand, iron 2 oxide is written like this. So the iron has a +2, oxygen has a -2. Let's circle them both. Let's crisscross. Crisscross. And guess what? Your 2-to-2 will eventually simplify to 1-to-1. So iron 2 oxide is written as FeO. FeO as in feo. Feo is Spanish for ugly, so now you can go around on the street saying, "Tu mamá es muy iron 2 oxide." So let's compare iron 2 oxide, which we just did, which was FeO, to iron 3 oxide. So this time the iron has a +3 charge, oxygen still has a -2 charge, and now all you got to do is just crisscross the charges. So this is Fe little 2 O3, and that is iron 3 oxide. And again, it seems backward. It feels kind of weird because it says iron 3, and then the formula has just 2 irons in it, but that's correct. We'll compare 3 different ions of iron. So iron is +1. Phosphate, because it ends in ATE, is going to be on that chart. The formula is PO4. The charge is -3. And now you just crisscross the charge. So you've got Fe3PO4, and that's correct. Let's move on. This one is iron now with a +2 charge. Phosphate is still the same. It's PO4 with a -3. Crisscross the 2 charges, bring the 2 down, bring the 3 over. We've got Fe3 parentheses PO4 little 2 on the outside, so 2 sets of phosphate. And now moving on, iron 3 is iron with the +3 charge, PO4 for phosphate. Crisscross the charges. The charges now are the same, so it's going to simplify, but just to be formal, I'll write out the work. So Fe3 PO4 3 sets. Cross them out so that they simplify, so it's just FePO4. So these are the 3 formulas. I'm going to go ahead and box them. Okay, and I want you to just study the differences between these formulas here. Notice how phosphate remains the same. Phosphate is unchanged. It's going to have the same formula, same charge. Your irons will have 3 different charges because it's in the D block. So it's got a +1, a +2, and a +3 version. And it changes the formulas just slightly. Let's try a different metal with a different polyatomic. So copper 1 sulfate. Sulfate is SO4 2-. Crisscross the charges. Copper now receives the 2. Sulfate is just 1 set. So copper 1 sulfate is Cu2SO4. Remember, we're just crisscrossing the charges. Let's move on. Let's try the next one. Copper 2 means a copper with a +2 charge. And we're going to cross this over with a sulfate, which is still -2. And because the charges are the same, you're going to see that they simplify, but I'll just show you the work. Simplify the 2's, and it's CuSO4. It looks strange, but trust me, that's copper 2 sulfate. Copper 3 sulfate has a +3 copper and a -2 sulfate again. So the sulfate does not change at all. Okay, but it will lend its 2 to the copper, and then copper will lend his 3 over to sulfate. So again, from left to right, those are the formulas for the 3 different versions of copper sulfate. You have a copper 1 sulfate, a copper 2 sulfate, and a copper 3 sulfate. So in short summary, D block metals can form various charges, and they have multiple types of cations. Their charges are not set in stone like alkali and alkaline earth metal families. As a result, they rely on a Roman numeral system in chemistry to tell you the charge. And keep in mind, it's always the charge and not the quantity of the metal in the formula. You're still going to look at their charges, use the crisscross method. If you have polyatomics involved, you're going to use that chart that we discussed in part 2, crisscross the charges, write down what you see, simplify the charges, and it's that easy. So this was Ionic compounds, parts 1, 2, and 3. Thanks for tuning in, and I'll see you next time on Win Chemistry.